Hello everyone. This is about earthquake waves. When there is an earthquake, the breaking or the slipping of the rock in earth creates vibrations. There are different types of vibrations. We call these vibrations waves, earthquake waves. They travel like waves. And there are two main kinds that we really focus on. S waves, P waves. S stands for secondary because they arrive second, they travel slower. And P waves are primary, they arrive first. Let's look at how they move within the rock itself, or this sort of motion that they make. So for this first one, it's going to play pretty quickly. Let's just focus on the S wave at the top. This is the S wave right here. Let's just focus on this movement here. That's how an S wave moves. Okay? And if I could bring it back here 1 second. I often think it is shaped sort of curvy like an S. So that's one way to remember it. So let's go back here. Now we will play the P wave. Let's focus down at the bottom how a P wave moves. Now this is often called like the P, people often use sort of push-pull. It is as if you sort of push this and pull it back, or you smack it with a hammer this way. Watch, hopefully you can see how these boxes compress here. See this here? You see this compression moving across right there? Okay, that is a P wave, and they travel at different speeds, with a P wave traveling faster, S wave traveling slower. That is an important distinction because how they move through Earth and different types of rocks and materials through Earth matters, and that is something that we notice. So now let's look at this. These examples right here. And give me just 1 second as I get to those videos. Let's do S waves first. So the S wave, if you will see, and they're going to simulate an earthquake happening. This is the surface of Earth, so this will be the crust. This is the mantle, outer core, inner core. And if we could have the Earth cut through, this is how the S waves travel through. Here we go. So that's the earthquake, and the white represents the S waves. And they travel like that. So the key thing here is, and there's more than just whatever, if there's 11 waves here. It is all of this. This whole entire ground shakes. They just can't show all of that. But so this whole area, I'm tracing with my finger from here all the way around down to here. All of any sort of locations that can record these vibrations, these S waves, they are all going to see S waves here. However, this whole part of the Earth will not. They will not receive S waves here, okay? So they would call it the S wave shadow zone. And this, if you were to do this math sort of backwards, we just see this on the surface. We figure this out backwards to say, well, there's something here that's stopping the S waves, and then we can determine that's the outer core. And the outer core, that's how we know the outer core is liquid, because we know by the nature of how S waves move, S waves do not travel through any sort of liquid rock. So that's the S wave shadow zone. Now let's go on to the P wave and see how that works. So here we go. So these are now going to show P waves as you see here. So similar thing, but this is the primary waves traveling through Earth. Let's see how that goes. So here's the earthquake. There's the earthquake. Those all represent P waves. And these are traveling through the outer core. And then I'm going to stop it there. Let's go back to, hold on 1 second. I apologize for that. Right there, we'll stop it right there. So this is different because the P waves, by their nature of how they interact with the rock itself, they are traveling through the outer core. But see, they get sort of bent there, bent there. They get bent a lot here. That's called being refracted, and that's because the densities of these layers are different. That's how we know that about in Earth is this refraction here, and that's what happens when waves travel through materials of different densities, and it travels through the inner core as well. But there's areas here on Earth that do not receive any P waves, and it's really this area here and also down here as well. Those are called as the P wave shadow zones, and they exist because this wave that would go there got refracted here, so there's a whole area where there's none. There's going to be another video that's going to show this on the globe on the surface. It may hopefully make it more clear. But so we have S wave and P wave shadow zones, and I really like the animation of how they travel through the Earth, and this should help you. We're doing the one, there's a coloring assignment that we do to help you learn about this even more, but this is really going to be a great introduction. So Mr. Gasta signing out.